Okay, hi all. I want to go ahead and do this video regarding our dry lab for Monday and into Tuesday, and then I'll be lecturing on Tuesday with finishing out on acids. Okay, so let's go ahead and jump over to OneNote. Okay. Up here I mentioned naming binary compounds, ionic and covalent. Unfortunately, the naming convention for ionic and covalent compounds are not the same, so we have to differentiate between the two. First of all, you have to figure out, are we talking about an ionic compound or a covalent compound? Now, just as a quick review, ionic compound equals a cation plus an anion. No exceptions. Period. No exceptions. And ionic compound involves the transfer that's the cation. Recipient, which is the anion. And because it's a transfer of electrons, you have to have a giver and you have to have a recipient, a cation and an anion. Okay, and then a covalent compound equals two non-metals. Ionic compound, by some people's definition, is a metal. The metal is the donor, the non-metal is the recipient. Okay, so I gave you this ion chart, common ion chart in my head. Okay, and as a review, I want to make sure, oops, I want to remind you those are metals. These are metalloids. And these are non-metals. Okay. So again, periodic table is mostly made up of metals. There are a few metalloids, and then there are a few more non-metals. And most everything is metals, which means that these are Okay, so the nonmetals mostly, if they're going to become ionic, become anions. The metals, if they become ionic, become cations. Okay. So if we were to have a compound, for it to be ionic again, it has to have a cation and an anion. No exceptions. So if we get a compound like common table salt, sodium chloride, is this ionic? Well, we need to look. Is sodium on the ion chart a metal? That's a metal, and it's also in our common ion chart as well. So one, it's a cation. Chloride is a nonmetal and forms anions. And okay, so it's ionic. Okay, so now we're going to use the ionic naming convention. Okay, so first step is determining, do we have an ionic compound, a covalent compound, and then tomorrow we'll talk about an acidic compound. Okay, it's an ionic compound, we use the ionic naming convention. If it's not ionic, then it's covalent. Okay, covalent is two nonmetals together. Okay, so let's look at, for example, water. Okay, we have, that's a hydride. That's an oxide. Both are nonmetals. I notice hydrogen over here is in the metals column. It's in the metal column in an acidic condition. It will be over here if it's in non-acidic. Okay, so we have H and O. H and O are two nonmetals. So, hence, water is because we have a nonmetal and a nonmetal together. Hydride is a nonmetal. Oxide is a nonmetal. So we're covalent. So now we're going to use the covalent naming convention. Okay, so let's start with the covalent naming convention first, because most students I've had over the years feel that that's the easiest. So we're going to use this covalent numbering system here, which you probably have heard of at least part of it. Mono, di, tri, octa, hexa, deca. You probably have heard those prefixes before, corresponding to a numeric number. You need to know all of these: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. Okay. All right. Those only apply for the covalent naming convention. Okay, so those are going to tell us how many are in the compound. So let's look at water. So we know it's a covalent, and hence we're going to use the covalent naming convention. Okay, so how many hydrogens are there? Okay, for both these conventions, it's going to be in two parts. So we're going to talk about covalent first. Okay. The first atom of the compound is going to be from the periodic table. Okay, so in this case, it's going to be hydrogen. If you look on the periodic table for H, it's going to say hydrogen. Okay, number two is, second part is going to be an ide. Now you can find the ides if you look on this ion chart I provided. Oxide. Okay. Okay, so we assign the first set of atoms per periodic table. The second one is going to be an oxide from the ion chart. So in this case, it's going to be oxide. The second thing we need to do is determine how many of the atoms of each. Okay, in the case of water, it's 2. That means it will be dihydrogen, monoxide. Now notice I don't have the O here, because it would be 2 O's together. We don't need to do that. We drop that. So if there are 2 vowels together, you may drop the second one. Okay, so it's dihydrogen monoxide. Okay, let's look at another one here. Let's look at that there, PO7. Okay, is this a covalent or ionic compound? Do is go up the periodic table, and both the P and the O are in the non-metal. So that means it's covalent. Okay. So it's going to be phosphorus, oxide, penta, hepta. Okay. We're going to leave off the A. So it's going to be pentaphosphorus heptoxide. So that's for covalent naming. So the first thing we need to determine, are we talking about ionic or covalent naming convention? So with covalent, most students feel this is the most straightforward. It's always in 2 parts. First we name the first one per the periodic table, phosphorus. The second one we name via an ide from my ionic table I gave you. And then the next thing we do is determine the number from our covalent numbering scheme. Okay, so these just need to be practiced. Okay, so what if it's ionic? Ionic is a little more involved. example, let's look at this here compound, sodium sulfate. Okay. First of all, sodium is going to be a metal. And this is going to be an anion, a polyatomic anion, sulfate. Okay. Okay. And when we're dealing with ionic compounds, you need to be aware of the charge. So sodium carries a plus charge, and sulfate carries a -2 charge. Now in nature, we never have an isolated charge. We always have to have neutral compounds. So if we have one sodium with one sulfate, that would not be balanced because we only have one sulfate to balance one of the negatives. That's why we have to have two positives to balance the -2 sulfate. That's why the formula is two sodiums at +1 apiece, +1, -2. Okay, so all ionic compounds charge needs to be a net 0 charge. Okay, that's based on the ion chart. Okay, let's take another example. Now, what if we were given a name of an ionic compound and I was asking you to write a formula for that? For example, aluminum sulfate. Okay, aluminum is a metal, and sulfate is on the anion side, being a nonmetal. So this is a nonmetal. So this is ionic. That means you have to do charge balancing. Okay. Sulfate is SO4, charge of -2. Aluminum is Al, the charge of +3. Okay, so if we wrote this as Al SO4, that would not be net 0, it would be net +1. So we have to modify the quantities of aluminum, the quantities of SO4 sulfate, so that we have a net of 0. So if we do 2 +3s, that gives us a +6. And if we did a 3 SO4s, that would be a -6. Giving us a net 0 charge. That is the basis of ionic naming and formula writing. We need a net charge of 0. Okay, so the formula is going to be Al2, 3 sulfates, SO4. Okay, so that's the essence of covalent and ionic naming. And also importantly, it's not only naming, but formula writing, particularly in the ionic. Okay. right, so I'm going to end this here, and I want you to look at that very long worksheet. We have 2 days to do it. And we're going to be practicing covalent ionic naming. Covalent ionic naming. Step number 1 is it ionic or covalent? And then that'll dictate what convention you're using, the ionic convention or the covalent convention. Okay,